When we talk about coffee's flavor, we often speak as if it is simple, as if the coffee gives us a sensation and we just read it. But neurologically, flavor is not that simple. Flavor is not a direct reading of the cup, it's actually a process. First, a stimulus is detected by the senses, then that information is sent to our brain, and then the brain organizes, interprets, and integrates those signals into a perception. So when we taste coffee, we are not just receiving information, we are constructing an experience. This is one of the most important things sensory science teaches us. In coffee, two systems are especially important: taste and smell. Taste happens when dissolved compounds interact with receptors in the mouth. On the other hand, smells happen when volatile compounds reach the olfactory system. And in coffee, aromatic compounds play a much bigger role than many people realize. Humans perceive smell in two ways. The first is orthonasal, that is, what we perceive through the nose from the environment. This is how we experience the smell of dry grounds or the aroma rising from a brewed cup. The second is retronasal. That happens when volatile compounds travel from the back of the mouth to the olfactory system as we breathe out. And this is very important and plays a major part of that flavor perception. In very practical terms, much of what we think of as flavor is actually from smell. That is why, if we block our nose while eating or drinking something aromatic, much of that flavor disappears. The product has not changed, but the brain is receiving less information to build the experience. What makes this even more fascinating is that the brain does not present taste, smell, and, carefully speaking, mouthfeel as separate things. It connects them. It combines smell, taste, and somehow mouthfeel into one unified perception that we call flavor. So, identifying flavor note is not only taste on the tongue, it is the integration of several sensory signals into one experience.